Welcome to notes 22-1 and 2. So we're not going to be using the notes from the book. Before you begin, you're going to need to go to the attached PDF and print these notes out. Okay. So this is on the Pythagorean theorem, its converse, and Pythagorean triples. So we're going to use the following handout to review the Pythagorean theorem and its converse. These notes will help you understand and recognize Pythagorean triples. The Pythagorean theorem states that if there is a right triangle, then the sum of the squares of the legs of the triangles is equal to the square of the hypotenuse. Oh, goodness. I'll have to shrink that in a little bit so you can see it. So the Pythagorean theorem states that if there's a right triangle, then the sum of the squares of the legs of the triangle is equal to the square of the hypotenuse. More simply put, leg squared plus leg squared equals hypotenuse squared. All right, or a squared plus b squared equals c squared. And again, like we've spoken about before, the legs are interchangeable. You can use either leg in either place because you're going to sum them up anyway, and the order that you add them won't matter. All right, so let's practice. It says find the missing lengths. So before you begin, you should always identify that this is your hypotenuse, this is a leg, and this is a leg. That way you insert these into the Pythagorean theorem correctly. All right, so we're going to have x squared plus 12 squared equals 13 squared. And so x squared plus 144 equals 169. And then we would subtract 144 from each side. And we get x squared equals 25. And then to find x, remember we're not looking for x squared, we're looking for x, and so we would square root both sides, and we get x equals 5. Now later on we'll see that when we square root we actually get plus or minus 5, but since this is a length of a leg, we cannot have a negative length, and so we'll only take the positive root. All right, the next one, number 4. This time our leg, and it's our hypotenuse that is unknown. Right, so we're going to use 4 squared plus 3 squared equals x squared. And that's 16 plus 9 equals x squared. 25 equals x squared. And so then we would square root both sides, and x equals 5. I should go ahead and put units on here, right? 5 miles. And on the previous one, it was 5 inches. All right. Number 5. It says that we're going to have a leg, and the hypotenuse. Also, in case you didn't recognize the hypotenuse, right? The hypotenuse is always across from the right angle. So there's my right angle, it's pointing at my hypotenuse. Here's my right angle pointing at the hypotenuse. And here's my right angle pointing at the hypotenuse, just in case you didn't recognize that that's the hypotenuse. All right, so we have x squared plus 13 squared equals 15 squared. So that would give me x squared plus 169 equals, that's 225. We would subtract 169 from both sides. And this gives me x squared equals, I'm going to have to do some regrouping here, just give me a moment. 11 minus 6 is 5. And so 56. Now this is not a perfect square. The previous ones were perfect squares. And so when you have a square root that's not a perfect square, remember you have to reduce it. We're not going to be using a calculator for these problems. We're going to be just reducing the radical. And so x equals, so the square root of 56 is 8 times 7. And 8 has a perfect square in it, which is 4. So this would be 4 times 2 times 7. And the square root of 4 is 2. So this will come outside of the radical as a 2. And then under the radical, we have a 2 times 7, which is 14. And this is in yards. All right, and the last one, go ahead and try this one on your own. Pause the video here and try it and see if you get the same solution that I get. All right, I hope you paused it and tried it. Here's our hypotenuse, right across from the right angle. Here's a leg and a leg. And so I have x squared plus 8 squared equals 16 squared. So that's x squared plus 64 equals 256. I'll subtract 64 from both sides. And I get x squared equals, that's a 2, that's 9, 192. Again, this is not a perfect square, so we'll have to simplify the square root. We get x equals, I'm running out of room, so I'm going to go to the next page. I'm going to go to another page. The square root of 192, right? I'm square rooting both sides. Square root of 192. I don't know a perfect square that goes into, I think maybe, no, I'm not sure of a perfect square. So I'm going to divide this by 2. So this is the same thing as 2 times, 2 goes into 19, 9 times with 1 left over, 96. And I still don't see a perfect square, so I'll take out a 2 again. So 2 times 2 times, 2 goes into 9, 4 times, 48. I see a perfect square now, there's a 4. I'm going to keep breaking down 48, so I've got, that's 4 times 48 is 16 times 3. And so my perfect squares would be a 4, square root of 4 is 2, a 16, the square root of 16 is 4, and then under the radical would be a 3. And so this would be 8 square root 3. So 8 root 3, and this time we're in kilometers. All right. So now that's the Pythagorean theorem, but there's a converse to the theorem. And basically a converse, just so you know what a converse is, a converse, it switches the beginning and the end. So this one said if there is a right triangle, or if the triangle is a right triangle, then what will happen is a squared plus b squared equals c squared. So what happens with the converse is that the if and the then switch. So this one's going to say that if a squared plus b squared equals c squared, then the triangle is a right triangle. So we use this to verify right triangles. Okay? All right, so it says the converse of the Pythagorean theorem states that if the sum of the squares of the sides of a triangle is equal to the square of the hypotenuse, then the triangle must be a right triangle. Or more simply put, if a squared plus b squared equals c squared, then the triangle is a right triangle. So again, we're going to use this to verify. So it says, are the following triangles right triangles? So what I'd like you to do, I'm going to pause the video here. I would like you guys to verify whether or not these are indeed right triangles by substituting these values into the Pythagorean theorem. I'll pick it up on the next video and I'll see you then.